Here's what I'm going to do. If this is a plane, guys, I'm kind of nervous because I want to generate an equation of plane out of thin air. I want you to believe me that this is standard form for an equation of plane. And so here's how I'm going to derive it out of thin air. You imagine a plane floating in 3 space, and I want you to take a peek at a vector that's normal to the plane. In other words, it meets the plane at a right angle. And let's suppose I've got a point in the plane. How about a piece of naught, whose coordinates are x naught, y naught, and z naught. It's some fixed point. Bless you. Excuse me. Notice what would happen if I chose an arbitrary second point in the plane. I'll call it P and label it x comma y comma z. It's any point in the plane. Then when I connect piece and naught to P and generate this vector right here, what's this relationship going to be to bar?
It's going to be orthogonal.
If things are going to be orthogonal, definitely the case. I think the dot product of the 2 vectors is going to be
0.
simply 0. The number is 0. Let me say that one more time. I think when I dot this particular vector here, I should be able to get a 0. And if my vector n bar has these components, you guys, I'm being honest. I'm making these letters up out of thin air. How about n bar being this? Then looking at the dot products simply means I've got this product. So the first one going to be x minus x naught, y minus y naught, z minus z naught, but the second vector, I just made up those letters again out of thin air, a, b, and c. And dotting, do I get this? Oh shoot, you guys look at that, it's a 2-liner. This is how I can generate the standard form for an equation plane. If a, comma b, comma c are the components of a normal vector to the plane, and x naught, y naught, z naught is an arbitrary point on the plane. This is going to be a standard equation. Now I got to confess to you guys, x naught, y naught, z naught, as well as a, b, and c are merely constants. So maybe an alternative form for the equation of a plane it could be generated by me adding those constants to the right-hand side. Uh-oh, did I just make a mistake? If it equals d, then d is going to be equal to ax naught positive plus by naught plus cz naught. I'm being silly. I'm just saying, take all the constants the other side. Nothing. And therefore, this is going to be an alternative form for the equation of a plane. And I think on occasion, sketching graphs of planes is going to be this easy. Let me start off my list of examples. And if I'm going to sketch the graph as plane, then I think if this is my x-axis, here's my y-axis, here's my z-axis, I think the sketch of this plane is going to be as easy as sketching lines. Or can I say it this way in English? I'll sketch the trace of this particular plane as it passes through the xy coordinate plane. Because as this plane crosses the xy coordinate plane, I think the value for z everywhere is going to be 0. So when I plug 0 for z, isn't that just the equation of a line? Whose x-intercept is 6, 0, 0. Whose y-intercept is 0, 3, 0. And I think if I plot those 2 points, they look something like this.
Wait, why did you say 6?
Well, if z is equal to 0, to find the x-intercept, what did I plug 0 for y?
Oh, okay.
Just double check my arithmetic. I think my y-intercept is going to be 0, 3, 0. But if I take a peek at the trace of this plane as it passed through, I don't know, how about the yz coordinate plane? That just means x is going to be 0. And if x is 0, I just get a line in the yz coordinate plane whose y-intercept is 0, 3, 0. Oh, I knew that. But whose z-intercept is going to be
002.
I agree. And so I think to sketch this plane clearly to the reader is just slicing through the first octant in that fashion. You guys, I know as a mere human being, I do a lousy job sketching as a graph because you're only seeing a portion of it pass through the first octant, but I assume it's for you, the reader, to understand. It's going in definitely in those other directions. What would this one look like?
Say that one more time.
Yes.
So,
I'm saying I know I'm kind of awkward as a mere human being when I sketch the graph of this plane because you understand that a plane goes in all different directions. And when I picture it on the board, I'm only seeing part of it as slicing through that first octant.
Okay,
But it's for
so-
you, the reader, to understand I really meant it to go in different all directions.
Okay.
So-
How would you go about showing it graphically that it goes in all directions?
Gosh, that's what I'm saying. It's so awkward. I
yeah.
probably have to do something
How
like
would you?
this. Because I'm behind the ink board, I'm below the XY coordinate plane, et cetera, et cetera.
I saw someone do just like two little lines, a double line and an arrow off the edge. It was kind of,
Yeah, I don't like that. See something like this?
yeah,
Something like that.
but a double line, double.
Oh, a double
lines.
one?
Yeah,
Through the side.
I can see that.
yeah, I don't know.
I think they're all awkward.
so do you really just care, or do you care if we just don't put anything like that, if we just draw the plane?
Yeah, I'm very happy with this.
Okay.
I mean, at least I showed you the intercepts.
Okay.
I've also showed you the lines for which the plane crosses through the coordinate planes.
Let's say, like, you have really bad drawing
Yeah.
skills. Can you just, like, do, like, the X, Y, and then, like, the Y, Z, like, just show,
You know,
like,
that's a
sides
good way of
and
doing it.
that?
Some people would say, well, to really get an idea what this piece looks like, let's imagine Z0. And let's just look at the XY coordinate plane. Here I think it would be tracing the XY coordinate plane. I think it would look like this. Sorry, I'm so slow. And then you would say, well, now let's consider the trace in the YZ coordinate plane. And jeepers, the YZ coordinate plane, that gives me 3 and 2. By the way, everybody, oh, big dot, sorry. By the way, everybody, I didn't mislabel this. It is 3 comma zeros in order paired in this one two-dimensional space, this particular two-dimensional space. And then I finally show the reader what the heck happens and what I'm missing, which would be the XZ coordinate plane. But in the XZ coordinate plane, I merely get this beast. Is that a 6 and 2? 6 and 2. Yeah, that'll work. So what about this one? What would that look like?
There, it,
Well, was it
there would
not-
be no, or just go flat along the XY axis?
Yeah, no Z component, yes.
Well,
Could
There's
you
no
read that
Z.
up, Bradley?
Well, Z would be equal to 0 through the whole thing, so it would just go along the XY plane.
Go along this way?
Parallel.
Or
I got it. It would be like a line, but then the Z, and Z could be everything, so you could just do like a.
I like
that.
He's saying this. I slice through the XY coordinate system this way, this
Yeah.
fashion. By the way, here are my ticks. It's just that I'm sliding that line up and down. And I think I get a plane that kind of looks something like this.
Oh.
That's one way I can visualize that plane. But here too, it's understood to you, the reader, looking at my nasty little picture, that I go on definitely those directions. By the way, do you guys remember in high school geometry how you defined the plane? Jeez.
That was freshman year.
Yeah, it was a long time ago. It was the same way you defined a point, the same way you defined a line. You didn't, you gave up and said, we're gonna consider this an undefined term. When we try to define it, it leads us to contradiction, so we just say, forget it. It's so darn basically understood what a plane or a line or a point is, we're gonna place faith in that everybody understands what it is without defining it.
So could you like put lines on that Z-axis? Maybe those double lines down, double lines up?
I don't understand where you can,
I suppose I could. Bryce?
so it's just that doesn't intercept the z-axis. That's the reason we don't have a
Now, that's
z-value there.
correct. This
Okay.
particular plane does not cross the z-axis anywhere.
Okay, so I get it.
Since it doesn't parallel to it, so there's no term.
You can say the z-axis is parallel to the plane. I'll live with that, yes.
Could I just draw a line and then make a note that says assume z equals 0? Just to,
No.
Yeah, because he's not zero, isn't it?
no, I know. I'm saying just for simplicity's sake, or maybe just draw a line and then draw arrows going out both directions, because, the less work I can do, the better.
So technically, what is z? Is z undefined, or is it? What would you?
Quite the contrary, z could be any real number you darn well please.
Yeah. That's what
I'm nervous about just saying draw a line and arrows, because I don't think that's as clear to the reader.
But if you don't have a variable z in there, can you explain that?
Yeah.
Okay.
Yes, let me do that. Get rid of this picture. If z is equal to 0, what's that graph going to look like?
Just
Just
a line.
It's just a line on the xy coordinate plane, pass through these intercepts here. But if z is equal to 1, then what equation do you get?
Math D.
Yeah, man,
yeah.
it's
Okay.
the same thing, isn't it?
Yes.
So I slide that line up 1 unit. And another maybe when z equals 2. Z could be anything. And I think I just simply get a collection of those parallel lines.
Okay.
Technically speaking, if I get a collection of parallel lines, I can subclassify the surface as a cylinder. Just a special case scenario.
How is that cylindrical exactly?
Well, here's my definition of a cylinder. It's a collection of parallel lines in grid space. No, that's not a cylinder the way you defined it back in high school geometry. Now just simply
31
redefine
or 30.
it. It's a whole new class, okay?
Say it one more time. What is a cylinder?
Collection of parallel lines in grid space.
Okay, well, that totally makes sense, but
Yeah, I think it does too.
well, you could draw it that way, I suppose, but what about the ends of it?
What ends?
The ends of the cylinder, the top and bottom of it.
Well, there might not be any ends. What about this surface? What's that look like?
It's a parabola.
No, 3 space.
Hideous.
It is not.
Doesn't it go?
It's a
plane where if you looked at its cross section of the XY, it would look like a parabola.
Okay, that's better. Or how about just a trough? Well, parabola will be a little bit different. There's gonna be some rotation. I think what in the XY coordinate plane, don't I just get this, you guys? An infinite trough, yes. In the XY coordinate plane, is this not merely its trace? So I think when I slide it along the z-axis, I'm going to get a surface that kind of looks like this. But it is a cylinder. It's a collection of parallel lines in free space.
I thought the cylinder had to be circular on its,
Had circular
on it,
bases.
if you took the trace.
Oh, that's so narrow-mindedly thinking.
But that's a cylinder.
Let's be free now.
I'm guessing it has to be like a collection, an infinite collection of lines, because like 2 parallel lines is hard to.
Oh. No, now you're stumping me. I'm serious, I just haven't thought of that. Yeah, I do think I want that by definition. I do want that.
What did
He
you
was
say?
saying, well, what if you just have a finite collection of lines? I wouldn't refer to it as a cylinder because that wouldn't be a smooth, continuous surface in 3 space.
So it has to be.
So he's saying I should add words to my definition by saying, well, there's an infinite collection of such parallel lines.
Continuous infinite.
Yes, continuous infinite.
I feel like you already said that at the beginning of the term, too.
If I did, that's great, but I don't understand.
2 questions. So does that curvature have to be differentiable, or does it care about any sort of kinks?
No, don't care about kinks.
Okay, that's what I figured.
So it might have an infinite many non-differentiable points.
Yeah, my other question was, what would be the point in defining that cylinder in that way? And what reason would you have for doing it?
Word for word. In maybe a college level geometry course, I might consider it not a cylinder but a pencil. Depending on my setting, I refer to that shape as with a different word. Depending on topic.
It's just because the cylinder happens to meet the same requirements as.
Yeah, the cylinder you're used to back in Math D certainly satisfies my definition. It's just in my definition broadens up more things.
doing so well on Friday.
What do you mean? Oh, gotcha.
There you go. You know, like if I could give style points, I would.
You do.
Little sticker. Eric style points.
I think I'd be running out of those pretty quick.
Was it you guys who told me the story about Professor, I can't remember her name, physics?
Aviva?
Aviva, yeah.
Wait,
What
wait,
story?
are you talking
What's the
about with
story?
Matt and the questions, or?
No, somebody was in our class and said, wow, your writing's just like Professor Balaguy.
Oh, that's
And she didn't know it was an insult.
She writes her mural.
Oh, really? I sure, you know.
She writes it like backwards, the long.
Oh, really?
words at the bottom. Or
Like this?
Yeah.
Oh, you mean the Y?
Yeah.
Anybody, I think, yes, Anthony.
So you get two vectors, and then you cross product them to get a normal vector, and then you dot them to make a plane.
I don't know if I have to dot them, I can just use my standard forms, but you guys, he's got the key to this. If I'm gonna create the equation of a plane, isn't it gonna be of this form right here? Or it could be of this form, it's one of my standard forms. Well, maybe not that one, but this one. Oh shoot, I forgot. Eric's here, I gotta slow down. And I think this is a nice form of equation of plane to look at because it screams out at me, I just need the point, a point, x naught, y naught, z naught, and I've got one. I've got three of them, choose any of them. And I need the numbers for a, b, and c, but those are just the components of a normal vector to the plane, and I can create a normal vector to the plane by taking any two vectors in the plane and looking at their cross product. Let's do it. Can I label the points a, b, and c? That is to say, uppercase a, b, and c. I think the vector AB in this direction is simply going to be, I don't know you guys, at -1, -1, 5. Whereas the vector going from A to C is going to be nothing more than, is that a -2, +1, and +1? And so I think n bar can be interpreted as nothing more than the cross product of AB and AC. Or shall we say it's a three-dimensional vector? And its components, anybody gonna help?
Nine?
How about -9?
I thought it's blah 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 minus blah blah blah.
Well, write it down the main data.
Oh, I forget, because it's gotta be the negative j hat. Very good. Keep on throwing me off on that.
I'm not trying to. Is that gonna be a -3? Yes, I'll write. Maggie?
Negative J hat, what was that?
Do you remember how if I expand this out, isn't it gonna be an I bar times a 2 by 2? Minus J bar times a 2 by 2 plus a K bar times a 2 by 2. That's all he meant by saying you get a sign change. Shoot, what's next? I said shoot, what's next? Just write the answer. I've got all the information. I got my A, B, and C. I got my X naught, Y naught, Z naught. A, B, and C is -0. Actually, what is A, B, and C? I've lost it. I can't read that. How about nice A, B, and C's?
-2.
How about +2?
Well, you can do that. 3.
Why positive
I think it looks prettier. Why not just choose a vector 2, 3, 1, because it's going in the same direction as well. Why not go smaller? You don't like what I'm doing? Don't listen to me. But when you write your equation out, if you divide both sides by -3, you get exactly what I have. So why not just do it? Is that giving is that a +3 times y? I don't know what's next. -2? And finally, plus my 1 times my z -3. Or if you prefer, I guess I can write an equation as a 2x plus 3y. Plus z being equal to, I don't know again. Is it 7? You guys are quiet.
Okay, so we found,
Well, to start, the vector AB, does it matter if you do B minus A or A minus? I feel like it should be B minus A.
Oh, you mean these two vectors right here?
Yeah.
Oh my gosh, I don't care at all. Just start one of the points and go in the other two, the direction of the other 2 points.
Okay.
And you could have started with a B and a C instead of an A, like I did. Doesn't make any difference, you just want to take any 2 vectors in the plane and look at the cross product.
So we found 2 vectors that lie within the plane. We found the normal vector to them and thus to the plane with the cross product. And then we substitute that into,
That equation up there.
okay, and that cross product has components A, B, C that we substitute in that.
Yes. And do you guys see why I'm saying I don't care what 2 points, which 3 points you pick in the plane? Because any 2 vectors in the plane are all going to go have the same direction in terms of the cross product. They might have different magnitude, who cares? I only care about them.
So the goal is a point and normal vector.
Yes, I agree. The whole point is, no pun intended, is grabbing a point and a normal vector. Yes. Caleb?
Sorry, where did the 2, 3, 1 come from?
I was just simply saying, wouldn't it be nice to just choose these numbers? I mean, the vector I found, that's a cross product, is simply a multiple of this one anyways. My numbers are small.
But that vector is it in a different direction or is it in the same direction?
Well, you're right, it's in the opposite direction, but it's still parallel to the original, isn't it?
But, and that's okay, it's
And
gonna
that's okay.
determine the same plane.
Direction's completely irrelevant. Well, actually, direction will be really important for us sometime this semester.
Okay.
Because if you end up with a one-sided surface, there's going to be problems with our calculus. You've seen one-sided surfaces, right? In 3 space you got.
How do you have a one-sided
Mobius strip.
surface?
What's that?
How do you have a one-sided surface?
Well, a Mobius strip is a one-sided surface.
So there's not another side to the,
Correct. Yeah. Do you guys know what a Mobius strip is?
I know what a Mobius strip is, yeah.
It's where you take a thing and you make a ring out of it and you twist it so
Yeah.
that you can follow the same
Yeah.
side all the way around.
Oh, see that?
English?
Because it's like,
Well,
This height.
Can you explain a one-sided surface, basically? Like,
If you continue along, eventually you end up on the other side, so it's all one continuous surface on both sides.
Okay, you know, what, I'm just gonna leave the draw pic, I like to make this, because what you're saying, I cannot picture.
because the point's all.
thank you so much. Man, you're always so prepared. I really appreciate that. Thank you kindly. So everybody, if I take this piece of paper, twist it 1/2 revolution, and then connect it,
Might be too thick, instead of idea.
it's so thick it's not a good one. I cut the
Fold it
piece.
in half maybe?
Yeah, either could do that. It's just awkward because I've done just that, I've made it too thick. But you check out what happens with this surface. Imagine there's an ant on the very top, and the ant's walking on the surface. Eventually it's going to be in the bottom, and then back on the top. So it's a 3-dimensional surface that is one-sided.
what if he was
You see-
walking on the other side?
Well, start the ant down here then. As he walks around, he's going to come to the top,
Okay.
then back again. It's a one-sided
Draw
surface.
a line along the ground.
Yeah, I know what you mean.
Okay. And I maintain, or sometimes I will say in English this semester, is a non-orientable surface. You know what's interesting about this? Is that when you see how I twisted it, 1/2 revolution. If I twisted it the other direction, 1/2 revolution, I get another Mobius strip that's not topologically equivalent to this one. I can't slide mine in 3 space to get right on top of the other one. We say they're non-topologically equivalent. You'd have to jump into a higher dimensional space to wrap it around the other one.
So are we actually going to be required to graph that?
No, but I'll require you to know towards the end of the semester that
Okay.
that will create the surface integrals,
Okay.
non-orientable surfaces.
You can't or can't?
Cannot. So what's a 4-dimensional analogy? What's the corresponding four-dimensional object? The Klein bottle, yeah.
What?
The Klein bottle? Never heard of it.
You know, I'm 0 for 2 right now, so.
And I'm doing the same as him, and I haven't even read like some science.
Are you gonna
fiction
drop
stuff, which
some?
has words like it.
I've got one in my office, you wanna look at it?
Fine bottle.
It looks like a test tube.
I can spell bottle, I really can. So you guys, the bottle's made out of glass, it's really hot. So I'm gonna put my hands on the neck, well, maybe not my hands, but some tools, and try to stretch it. Now with my finger, I'm gonna poke a hole in it. And I'm gonna bring the spout and connect it to the bottom. And I think the Klein bottle looks something like this. You guys know I can't drop it. Maybe you'll get the idea. I didn't hear Now, if you have a hand on the top, on the outside of the spout, it walks. But now it's on the inside of the bottle. It's inside the spout. But that it carries, as it goes through again, it's now on the outside. It's a one-dimensional space.
I'm confused.
What happens if it goes water?
You know, last time I brought this to one of my classes, like 2 semesters ago, I didn't notice some guy in the corner, he actually filled it with water. To get the water out, it was awful.
Okay, how,
He take a whole blow dryer to every day.
so how did it work again? You start on which side?
Well, I'm just saying, take the spout, poke a hole, pull the spout in, and connect the spout to the bottom of the bottle.
Okay, so.
Go by my office, look at my shelf.
But that hole is open, right? There's space around.
Okay, I don't know. Now, as a mathematician, I've seen this defined 2 ways. One way, like I have it, so the ant can fall. But other people's version of the Klein bottle has it connected, like the one in my office. And the reason why that's legal is because in 4-dimensional space, you can travel through.
Okay.
So I've seen the model expressed in both fashions.
So what do you mean by being a four-dimensional equivalence?
Mobius strip is a 3-dimensional image. Some people would consider this a corresponding 4-dimensional analogy of a Mobius strip because they connect glass here and seal it in. But in higher dimensional space, you can walk through.
So.
I heard one of the generals of the Luftwaffe, not the Luftwaffe. No, the foot troops in Nazi Germany.
The Wehrmacht?
Well, it was just one of the colonels. He later became a general. I can't remember who he was. He got so pissed off going into the Eastern Front, into Russia, with all the maintenance problems they had, particularly with the belts they had to keep replacing their vehicles. He demanded that his engineers design a belt that would last a lot longer than standard belts in car engines. And so the engineers immediately came up with the idea of using a Mobius strip. In the end, it didn't end up working because to keep it in position, there had to be a second pulley, so it kind of defeated the purpose. But they tried.
So the lesson of that story, the moral of that story is never start a land war in Asia.
One semester not long ago, I had my DE students, they gave me a gift. They gave me a scarf. It was made in the form of a Mobius strip. But they gave me a matching, what do you call those, beanies? It is a Klein bottle.
How come you
My
never
wife
wear
does
it?
not let me walk out of the house with it. I hide it in my bag.
Oh, I was just saying, how come you never wear it?
But
You just said, yeah.
Wouldn't that make it like a sash instead of a scarf? It's connected to both ends of the Mobius strip. Oh, you got it.
where am I at, 5?
Yeah.
Oh, and do you care which form you write the equation of the plane in, unless you specify? Either one is fine.
No, not unless it's specified.
No, because it goes through it instead of, it's not filling it, it's not, it goes right through it. Makes sense?
You know,
No, you won't, it's just neat.
Eric too.
3x plus minus something 2 1, what?
Negative 3x plus 2y plus 1.
Oh, I was just trying to figure out what option we.
Anybody just wanted to talk? Say something.
So what's the
Yes.
second
The
equation?
first one,
Plus?
there are two planes that are parallel.
How do you know that?
Because if you divide the first one by, if you divide the second one by -3, then you will have all the x, y, and z coefficients.
And that's how I created the two equations. But how do you know that means that they're going to be parallel?
Because they're never gonna intersect each other, because there are two equations that are exactly the same, that equal to different constants.
You're right. I just don't think the justification
Yeah, it's
is
not
there.
the justification.
But you are right. Thank you. I think because I got two planes whose normal vectors are in the same direction, then the planes themselves have to be parallel.
Say that again, please.
Yes. Because with these first two planes in that first example, part 1, because their normal vectors are parallel to each other, the planes are parallel.
How are they parallel?
Well, do this.
Oh, I see.
If you got two planes whose normal vectors are parallel to each other, the planes actually on top of each other or parallel to each other?
I thought that was like a forward line, I'm just seeing double for a minute.
Oh, okay, gotcha.
So we did have normal vectors with points, how do we know what they are from the equation?
Yeah.
Can you say that again? I'm sorry, I don't understand.
How do I find a normal vector from the equation?
For the equation of the plane?
From that equation, like, we found normal vectors by
It's immediate.
points.
It's immediate. A normal vector to this plane is 2, 1, -3. Those coefficients, my A, B, and C, from my standard equation of the plane. Or how can I say it differently? Can I call it N1 bar and N2 bar to finish my sentence? -6, -3, 9, but clearly N2 bar is parallel to N1 bar because they go in the same direction. Well, opposite direction, but they go parallel. What can you say about my second example, part 2? Oh, really? Really?
Well, one of them
What's supposed to be in there?
parallel to the z-axis.
B is understood to be 0.
But what's on the z? Is it a plus or a minus? Excuse me, on the y.
Oh, no, it's nothing. Linda, I wrote it down incorrectly. Sorry. You guys gotta change that? My apologies. Oh.
Well, but
There's just a blank where
But
there
there's
was
no
no orthogonal
added-
vector.
added-
Okay, if you want me to put it in, I'll put it in.
well, they
There's a
say
plus. You needed a plus or a minus in front of it.
Oh, the Z term. My
Yes.
apologies,
Yeah,
Linda.
that,
I'm sorry.
there was no operator there.
Gotcha.
Not confused.
I didn't notice.
Okay, so
Anybody want to panic, Matthew?
You can try to find out if they're perpendicular
How?
by taking a cross product.
I'm too tired. What's an easier one? Say it again.
Multiply them both by a coefficient of c, you can cancel a variable out, and then add them together.
It still sounds somewhat complex.
Equals 0.
Perfectly put. Let's just you and I compute the dot product of two normal vectors. Clearly, the way I made the example, it turns out to be 0, which means if the normal vectors of those two planes are perpendicular, that means the planes have to be perpendicular.
So the dot product of the normal vectors must be
Yes.
0.
Which in this example is 2 times -3 plus 1 times 0 plus -3 times 2, which is clearly 0. That's why I made the example of it.
Clearly not 0, it's -12.
Wait, what?
Oh, be quiet. Now do it.
There you go.
I'm sorry for messing up that example 3 different ways.
How did you change it?
I changed it with a plus sign. Linda, because
Okay.
I had a -6 -6, which to me was 0, but apparently with you it's not. So.
So they're perpendicular.
So are you doing anything with a D, when you talk about cross or dot product?
I don't think I have to worry about the D. No, in a sense I do. The D comes into play in the fact that the planes in the first example, part 1, were parallel, not on top of each other. I know they're parallel to each other, not on top of each other, because I admit there's a scale change of -3 from every symbol here to the corresponding symbol here, with the exception of the constant, the D number. And since this is not -3 times that one, I know this plane is not a duplication of this one. I know these two planes are not coincident. I know they're not on top of each other. I know that they don't have, I know that they do not have any points of intersection.
So if that was the case with the constant, then you would have them on top of each other.
Now, that's true. If this ended up being a -6, that means the two planes are equivalent. They have the same quenching points.
So I was reading something about the V that said it could be thought to represent the distance from the origin if you were to draw like a position vector. Is there any truth to that, or is it kind of hand wavy?
Yeah, I'll even put that in the form of theorem.
Okay.
I can do that. Do you think there's going to be an intersection?
It's like there could be, having trouble picturing it. Yes.
Why would you say you know there's an intersection?
You said
How can you say that?
Orthogonality? Between the
That's too
vectors?
strong. Say something weaker. Non-parallel. I think at a glance, since one normal vector is not a multiple of the other, then these two planes have got to be intersecting somewhere, because they're definitely not parallel. So what is their intersection is not parallel?
if their intersection, they're not parallel.
If two planes are not parallel, they have to intersect, but what's the intersection going to look like?
It's gonna be the point where they're
It's going to
actually.
be a line. So, how do you find the equation of the line?
You do the, oh, you have to get the,
Get
point,
one
I would
just
say, and there's, get, what's the,
Just like take x on one side and solve for x on one of them and substitute that in for x on the other, maybe, and then you'll get a line in terms of y and z where they intersect.
You know what, I'll do that to find a point on the line. That's true. But what about all the other components of the line?
you have to do the cross product to get
What?
the, of the normal vector to get the other vector, and then you, like, get the equation.
Do you guys agree? Check this out. Two planes intersect. Here are their normal vectors. If I simply look at the cross product of those normal vectors, isn't that going to be another vector parallel to the line of intersection of the two planes? So I think what I'm going to do is take a peek at the cross product with the two normal vectors. And I think I'm going to